I think we'll get right to it and dive into the different case studies. So I'm very happy to start in Italy, in Europe. We have Roberto Bertelli, who's the sales director for AB Energy, and he will be speaking about an interesting application of trigeneration. The floor is yours, Roberto.
Thank you, Hans. Thank you, President. And okay, so good morning, good afternoon, and good evening to all ladies and gentlemen connected, and welcome to this webinar. I'm Roberto Bertelli with AB Energy, and the title of my presentation is Perugina, the Sweet Trigeneration. This is a very brief, let's say, the agenda of the today presentation. I will start with an introduction, very brief, and then I would like to share some thoughts with you regarding the cogeneration definition, just to share some thoughts together, and then I will go to the case study and the project details, and then through the conclusions with the benefits and results and the conclusion of the presentation. Just a very brief introduction, just using just this nice image to introduce the end customers that made the investment for the trigeneration plant related to this case study. So the name of the company is Perugina. Perugina is a famous Italian chocolate producer, and in the picture there is their main, but also the worldwide known product. It's a sweet, a chocolate sweet, called bacio. Bacio means kiss. Is a very famous sweet used in St. Valentine's Day. So very famous, and that's why I named this presentation the Sweet Trigeneration. No? So just to smooth the technology together with sometimes the products that have been produced by our customers. Then, as I mentioned, I would like to start from the cogeneration definition. So, of course, I don't want to bother nobody because we all know the definition of the cogeneration. But every time I analyze a new project, I always ask myself, are we applying this definition in a proper way? Because it seems a simple calculation, but it is very important to recognize that we are saving primary energy, we are saving fuel. So that means that we are reducing emissions. So that's why we firmly believe that the cleanest energy is the one that is not burned. So let's keep this definition on top of this page, because I want to continue. I would like to share the following thoughts, and in particular this one. So talking about fuel saving. So have you ever compared the fuel saved from a CHP plant with, in this case, for example, with the fuel saved from a photovoltaic system? Of course, talking in general, photovoltaic is a pure green energy production. Of course, it follows the sun, so it doesn't produce thermal energy, so it can work 7 days per week, and it is good for those companies that work 1 or 2 shifts. I put here an image regarding a profile, a consumption of profile, electrical profile consumption, just to facilitate, no? Because of course, following the sun, maybe the photovoltaic can peak the shave, they can shave the peaks, no, during the day, can support, no, the grid stability. But then we have cogeneration. Cogeneration produces by definition energy efficiency. So we are producing heat and power in continuous, so it is good for the free shifts. So these are the general comment. But then we can dig more and we can compare. If we take 2 plants with an equal electrical power, and using the definition of the cogeneration, how much fuel are we saving? So if we take the case of photovoltaic, an average photovoltaic can run, let's say, 4,000 operating hours per year. But if we consider the peak equivalent, of course, we have to reduce to 1,100. So if we take the number of the examples, so the 102 kilowatt that you can save for the primary, let's say, energy used, and you multiply for the hours of the peak, you can save 112,000 kilowatt hour per year. Let's make a comparison with the primary energy fuel saving from a cogeneration. A cogeneration plant, in average, can generally runs more than 6,000 operating hours. Can be 7,000, can be 8,000. But let's take the example of 6,300 operating hours per year. So the primary energy used saved is around 1/3, no? So the famous 55 kilowatt. That means 330,000 kilowatt hour per year. So we are talking about considering, let's say, the working year, the CHP can save more than 3 times the fuel compared to the PV system. Of course, this is a very small exercise, but can be, let's say, we can make more deep, let's say, calculation, but more or less these are the calculations. So that's why cogeneration is good for the environment, as a technology is good for the environment. Of course, maybe someone could complain about where is located this saving. Okay, but to this statement, I could answer with a question. So because at the very end, is the CO2 emission a global problem or a local problem? I mean, a backyard problem. So this is a key question to me in order to understand what we are talking about, because at the very end, by definition, cogeneration produces efficiency. So the question is what to do. So let's say, in my opinion, it is very important not to create useless competition among the technologies, but instead it is key to combine them to maximize the benefits of the cogeneration, because the cogeneration technology can concentrate a lot of activities. For example, emissions treatment. The emissions treatment, talking about engines, turbines, whatever, the technologies to treat the exhaust gas to reduce pollutants after the combustion are known and very well performing. And acting on the distributed power generation, we can further clean the emissions for these plants. And of course, distributed power generation can support the grid stabilization, so increasing also the resiliency of the plants of the grid. And then, of course, this would be the best case scenario. No? Of course, CHP plants can use natural gas and produce efficiency, but can use also biofuels like biogas, renewable natural gas, or, as the president mentioned, the hydrogen. So I would conclude with also the combination of the cogeneration with the renewable technologies. We mentioned the photovoltaic system, but combining these technologies, in conclusion, we can say that we can only add huge advantages in designing the best sustainable solution possible. So here I would say, putting all together, a well-designed solution, a well-designed sustainable solution can bring positive advantages at many levels. So of course, for the environment, for the company's reputation, of course, it's a way also to reduce the cost and, as a consequence, also to increase the competitiveness. But it is definitely a responsible and sustainable answer to the energy crisis that in some countries more than others, maybe it is perceived higher than in other places. So as promised, I would go to the case study. So first, I would like to share where we are. So we are in the center of Italy. This plant is based in the center of Italy, not far from Perugia. I've already mentioned the company Perugina. Company Perugina is owned by Nestle, the very well-known multinational company, leader in the chocolate production. And here I would like to mention from where we started, from where the project started, because Perugina company, for this company, the trigeneration experience started, let's say, almost 20 years ago, when AB installed two plants, two cogeneration plants plus an absorption chiller. So altogether is a trigeneration plant. We installed two units, 3 megawatt each. Of course, Yamaha engines with the model J620. And then the customer recently, so in 2019, after 2 times the engine's lifetime run, so after having squeezed the potential of this plant till the very end, the customer decided to renew the entire plant. And that's why, together with them, together in particular, of course, with the energy manager that knows the facilities and the consumption and the needs, we dig into the customer profile of consumption in terms of electricity and heat needs. And I would say that this is the most important phase of the designing plant, because the energy audit is key in order to design the best solution possible. And in this case, of course, the final result was still very close to the 6 megawatt plant. So the customer chose the combination of these two plants. So one engine 2.6 megawatt plus another engine 3.3 megawatt, and of course steam and hot water production. The hot water, it is used for to feed an absorption chiller in order to produce chilled water, more or less 5 degrees, that they use for the chocolate molds and also for the process, of course. Then once defined the plant dimensioning together, we draw the project goals. So we gave ourselves specific goals. Of course, we started in positioning the plant. So together we found a new area for the CHP, not far from the other one. So here you can see the very old one. And then we, considering the new plant come after many years from the first one, so the new solutions design keeps into consideration the improvements made by the engine manufacturer on one side and made by AB on the other side, in order to reach specific goals. Like, for example, here you can see the difference in electrical efficiency. So 20 years ago, the engines were around 40–42%. Now the efficiency is way better. And of course, having chosen two different sizes of the engine, we increase the scalability of this plant. So now is more the plant is more flexible and can it's more easy for the production site to manage the loads. So as far as we follow the production loads, is more easier this way to program the engines in order to follow the customer loads. And of course, it helps also the fact that the new engine 620 has, of course, has a better efficiency, but it also increased the production. So this way we were able to combine the two units, one bigger and one slightly smaller. Furthermore, in Italy, we have this possibility in Italy, there is a mechanism to incentivize, to promote the energy efficiency, and cogeneration, by definition, is part of this program. So producing energy efficiency, you can obtain the so-called white certificates. These certificates can be easily sold in to the market to further speed up the return of the investment. So they are very good for this. Here is also connecting, so just to make a connection to what I explained earlier. In this production side, the customer installed also a photovoltaic system. Here we are talking about 1.2 megawatt as a peak. And together with the CHP, of course, playing with the CHP plant during the day, we are able to follow the customer needs. So here is very easy to, I mean, the plants is very easy to program the plants in order to buy as less energy possible from the grid and use the self production. And I think that this is a tangible demonstration of that these technologies can easily work together, increasing the overall positive impact on the environment. Here, just to share some details about the project layout. In this case, we have positioned the new plant in a new area, but not far from the old one. This was very important during the installation phase, but also during the startup, because we had the chance to very quickly switch the plants, reducing the plant downtime for the customer. And this is the final result of the plan. So everything is in package. So the integration with the plant, with the production side of the customer is very easy. Then I will go straight to the benefits and results. And here I would say that benefits and results, we can say, talking again about cogeneration, that there are two levels of benefits and results. Of course, one part of the benefits are related to the cogeneration or trigeneration plant. In this case, the price of electricity and the price of the gas in Italy, and also the so-called spark spread, is very good for this kind of installation, because the price of electricity and price of the gas are very strictly connected. And of course, also having the support from the white certificates, let's say the overall payback of the investment is quite good. Of course, the other advantage that is, to me, quite important is that the plant renew brings better performances. That means having further fuel saving and, of course, further emissions reduction. And of course, together with the photovoltaic integration, as mentioned, so we also obtain a very good level of resiliency, and as far as we are less dependent from the grid, of course, we have a very good level of stability. Of course, these plants are also good at another level, so at the corporate level, because these companies all have the specific targets in terms of energy savings per tons of products, water savings per tons of products. Also, the waste has to be managed, and of course, the CO2 impact, the CO2 footprint for these companies is important. So, putting all together, these plants brings this kind of results. As a conclusion, I would say, I would like to highlight how a trigeneration or a cogeneration plant is still a great asset that permits to reach great goals in the transition period. So goals that might be in terms of energy and money savings, of course. The technology combination can bring further CO2 reduction. The respect of the environment, of course, is of course, having a better image of a sustainable company. Very last point that I wanted to share with you. You can find this case study also as a video in our Cogeneration channel, because there is a AB published Net Zero Tube, not to promote AB or our technology, but to our product, but to promote the technology. So Net Zero Tube is a collector of the free web channels, no? So that is Cogeneration channel, biogas channel, and biomethane channel. So here you can find hundreds of video interviews to experts, to customers, to people that want to share their experience with this technology. So it is a good tool to spread the culture of the cogeneration. So I thank you for your attention, and of course, if you have any questions later, I'm here to answer, or you can always email me to my corporate email, roberto.bertelli@gruppoab.com. Thank you, and thank you, Hans.
Thank you, Roberto. Thank you for a very comprehensive and also very interesting case study. Trigeneration. You don't have too much around the world today, but it's certainly picking up, especially when you need a combination of heat and cooling for different applications. So very interesting case study.